All right, ladies and gentlemen, here goes example 4. This one's a little bit wordy and at first could be a little confusing, but follow along with me and I think we'll get through this just fine. A satellite TV, so this is kind of like one of those real life examples. A satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results given as joint relative frequencies are shown in the table, in the two-way table. So the 3 cities are Glendale, Santa Monica, and Long Beach. These are all in California, I can pretty well guarantee you. At least I've heard of Santa Monica and Long Beach, and I think Glendale as well. Now, with that said, they either respond yes or no. Are you going to recommend or are you not going to recommend? 29% of people in Glendale said yes, they're going to recommend, and 5% in Glendale said no, they weren't going to recommend. Notice how that doesn't equal 100%. Santa Monica is 27% and yes, and 3% no, 32% yes, 4% no. So maybe there was an option for other and they're only looking at yes and no. There could be a lot of different reasons why these don't add up to be 100, but if you look at the total population, this is what we have. We have only the relative frequency. Now, what is the probability that a randomly selected customer who is located in Glendale will recommend the provider? It is not, will recommend in Glendale, it is not 29%, okay? The probability that they will is gonna be the probability that they're in Glendale, they said yes, which is 0.29 or 29%, but you have to divide that by how many people are in Glendale. In other words, you have to account for both the yeses and the nos in Glendale. So if we take 29% and divide it by that same 29% plus the other 5%, what you get when you solve this is about 0.853. So there's an 85.3% chance that someone in Glendale will recommend the provider. Now that's all of Glendale. That's not of just the small population asked. So again, they took the survey, and turned it into a way to be able to predict how many people in the total area. Just because 29% said yes, according to the relative frequency, that leads to expecting 85.3% of the total population to say yes. Now, what is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So here we have to take the idea that it's no and Long Beach, and where it matches is right here. So we're going to take that 0.044% chance, and we're going to divide it by the total amount of people who said no, because we're worried about the no. That's the part. So we have to add up the 0.05, the 0.03, and the 0.04. When we do that, it's gonna, I better do this. It's gonna be about 0.333, or a 33 or a third chance. So every third person we could expect would be in Long Beach would say no, they don't recommend. So then determine whether recommending the provider to a friend and living in Long Beach are independent events. In other words, does their opinion in Long Beach directly affect whether it's going to say yes or no? And we can do that by comparing the probabilities. If the probability of being in Long Beach is equal to the probability of being in Long Beach and saying, what does it say, the provider, that they would recommend, so that's a yes. If they match, then they're independent. If we find each one independent of the other to be the same probability, then they are independent events. So let's take a look at it. We already know that Long Beach and yes, just being in Long Beach, I skipped ahead to the second part. If we're talking about Long Beach would be 0.32 plus 0.04, because that's the total amount of people who lived in Long Beach. That is a 36% chance. that you live in Long Beach. Now, the idea here is if we take Long Beach and compare it to yes, because that's what we're asking, would they recommend if they're in Long Beach, is that dependent or independent of just living in Long Beach? So if we find the amount of people who would say yes in Long Beach, now that's 0.32, and we divide that by the total amount of people who said yes, 0.29 plus 0.27 plus 0.32, we find that it's about 0.36. Now, we say about because there's some rounding there, but it's close enough to be that 0.36 is equal to 0.36, and both were calculated as independent events, and they came to the same percent. Therefore, they must be independent. Being in Long Beach does not form your opinion that you will or will not recommend this TV service provider.